Let us let us find out a way to design a schema for a fresh idea you got um, from the ground up. Say you want to develop some web application or some e-commerce application like eBay for selling and buying the agriculture equipment. So you have to know what are all the agriculture equipments, and you go to some websites like who are all the manufacturers of that equipment. For example, John Deere is a very famous manufacturer, and they produce a lot of agriculture equipment and other lawn and other equipment. Also, there is another manufacturer, Mahindra, and they are very famous for tractors. And so they will sell a lot of vehicles, different models they will sell, and for different needs. If you have a farm of, say, 10 acres, you may need a small tractor. If you have 100 acres, you may need a bigger tractor, and you may need different other equipment like harvester, seeders, and say fertilizer spreaders like that. So the there so the all these different various equipment and models, and say somebody wants to sell his whatever equipment he has, say some used equipment like eBay, then they have to specify all the models and manufacturer and um, what year they bought and how old is it and what is the condition and all that. Preferably, they have to put some photos of their equipment and in what location it is there, at least in the zip code they have to specify, so that the buyer will come and buy it, choose the nearest location and most suitable equipment for him. So, so we need the manufacturers, and we need the what is that models, and also we need the product line. Just by seeing the model number, the buyer may not understand is it a small tractor or utility tractor or whatever. And so all that static meta information or information about information, I use the term meta, we have to maintain as a static tables for the application. Though you have to keep updating them with the latest information, but for application point of view, if somebody wants to sell a unit, then they can just choose the existing information and sell his attach his unit to that meta information and upload his photos on the website so that it can be sold. So let us build a small front-end application with all that and all that information, and that looks like this. Um, okay, like this. So what are the mission types, these things, and is it a user or new, and fuel or electric, and you want to buy or sell or trade or rent, like that. So, and say I want to search in this one, this many miles, this is my zip code. And so right now I'm only listing the manufacturers like this, John Deere and actually models, John Deere and this is a utility tractor. And that's why John Deere is appearing in many places. That is another problem. So I'm repeating the manufacturer several times here just because my model is changing. And when we start this application, when you get an idea, you try to put that into a paper. That is nothing but paper means a program in this context. So I put the same way the idea into this context and gathered all the manufacturers and what are the models and product line and what is the price, latest, the new unit price. But if somebody is selling his unit, used unit, his price will be far lesser than this. And so for a small application to start to prove your idea, it may be enough to put in the program itself and see how it looks as a prototype, and to refresh how it looks in the screen. But once you want to deploy into a cloud or any servers, and keep updating this string and redeploying if you have any live users, and many things will go wrong, and it's not feasible even if you have redundancy and all that. Um, for this reason, this is not a good reason to deploy a code, because you have one another new model or another new what is that manufacturer. So maintaining this data is a what is that flat file in within your a program is a bad idea. So what is a good idea? The good idea is to develop a um, database schema for this maintenance. And advantages are, one, you can um, you can update the schema without redeploying your the metadata, without redeploying your code, and so that you are not hard coding into your application itself. And let us go and build a database for this information. So this information in database, actual the collection of these tables and whatever artifacts you need for this your application is called a schema. So the schema is a namespace that contains named database objects, tables, views, indexes. Together is called a schema. So within a database, you can have many schemas. When you create a database, you will get a one default public schema. So generally, folks will use that to define these tables for that application, and they create a separate database for each application. Um, so within that application, if you want a different what is that different namespace, then you will create a different schema. But that is a bit rare. So, um, so we could create a new database, say, schema, like this, and then create the tables and go to schemas and public schema and create the tables and triggers and all the artifacts you need for your application. But today we will teach you, because we had all the schema already available, so it is convenient to show side by side. So we will create a schema within this same database, form equipment database, say tutorial schema. Okay. Security is the Postgres user will have the access. The Postgres user will have the access. Let's go with that user, because I logged in that user. So you will have access to everywhere. Now, this information I have divided into manufacturers, so that I don't repeat the manufacturer name for many times for each model, manufacturer name. Then each manufacturer will uh, uh, each manufacturer will produce or offer many machine types. He can sell tractors, he can sell seeders and plows and other things. So the one thing what we need to understand is when we create the the art is here dividing this information into multiple tables so that we can avoid the repetition. And the other thing is choosing the columns and their data types. So it may not come in one shot, but once you have the schema, then you can revise it and rearrange the columns, drop the column and add the column to some other table where it makes sense, or where the repetition will be very less. For example, for a manufacturer, I have a country ID, a country column here, but later I dropped it. We dropped it because now the manufacturer all are very international and they sell their equipment everywhere. And it doesn't make sense to create, maintain a column for the country for the manufacturer. But the user who is selling his item or equipment, he sells in a particular zip code in particular country. So it makes sense to add the country to the country code and the zip code to the particular equipment they are selling. So it's available, say he's selling for, say, some Texas, San Antonio County, or some other county. So it is better to put state code and country code and zip code. Say state code. I forgot the state. So it makes sense to put the state. So the database design is a evaluation or evaluating exercise. And so you have to rearrange the informations as you think, um, uh, as you process the thoughts. So it is more of a science than it is more of a art than science. Though the actual technology is a science, but actual designing and rearranging the things and doing it is art. So the perfection comes um, um, you keep on doing it, like anything, like music or anything. So this information I don't want to keep in one table, so I divide in such a way that the information won't be repeated, and it makes sense for the my business model. So I kept the columns, manufacturer's name and manufacturer ID here, and then machine types um, here. So machine name ID and types in a separate table, and then the thing comes about the model. For example, if you go to this one series, the actual tractor you buy is a particular model one. So within the small one series tractor, there are two models. So model is the one which is the lowest model type is the which is the one lowest denominator to purchase any vehicle. So this is the model we are maintaining. So model number, product line. So for example, here you see compact tractor, or here also we are more maintaining this product line. So that we are fitting into this product line column. Then machine type. Here comes the foreign keys. See, machine types and manufacturer ID, we are not repeating it. We are actually maintaining in these individual tables, but borrowing their key into this model table. So we first toyed with keeping the what is it machine type within the equipment, or but it didn't suit, because people will sell, say, 1,000 pieces they sell of particular machine type. It is waste to repeat 1,000 times. So move to the model. it makes more sense to carry the machine type and manufacturer in the model name, model table. But again, does it make sense to repeat the machine type description and manufacturer name for every model, or just carry the machine type ID? Um, so that's a good candidate for the foreign keys. So uh, we created the foreign keys for the uh, created the columns for the machine type ID, manufacturer ID, and attached to the columns of this other tables, machine types and manufacturers as a foreign keys. Then comes to the then you have the metadata needed to describe a particular type of equipment, that is a model, subcontract model, this is the model, and what is the horsepower and all that. Then say if somebody wants to sell that this type of tractor, say after using 2 years or whatever, then he will come here and he will choose the model. When you choose the model, automatically, because you have the foreign keys, you can extract the machine types and manufacturer name. Then all he has to do is put his number plate, registration number, and other details, user months, and is it electric or actually electric or no electric comes from the machine model type. So we could move that EV to the machine type. This we have moved it here, EV. And user or new is subjective to the particular equipment. So that should be here. Price is price of that particular equipment. So it should be in this equipment table. And Jeep also where that actual the farmer is owning his Jeep, this equipment. Is it certified or not? So the idea is to sell the equipment, uh, go to a nearest dealer or get the certification of that equipment. So that is one business model, selling a non-certified vehicle, not equipment, and certified equipment. Um, so carrying EV in the model, okay, model makes more sense than the if it is EV, non-EV, then electric or non-electric. If say John Deere sells both electric vehicles and non-electric vehicles, then the model will be different. There will be 23, 24E or something like that. Same as here, subcompact and compact and utility and all these things. So the models, utility, this ones, what are the models here? It's 5500, 6000, 7000 models. So we should maintain the EV in the model, not in the each equipment. So let us drop this column here. So this how we start reiterating, means start improving the schema design. So let us do it in live. So 4 tables are there, and I created the tutorial schema and tables. And so let's start with the lower denominator tables, that is manufacturer. Manufacturer. Okay. And what are the columns it has? It it basically needs to keep the name of this name of the manufacturer. But the very fact we are maintaining a separate table is we don't want to carry the long name we in the program internally. We just want to take some ID. So in good old days, we used to keep the sequence number as the identifier. But the problem with that is if you migrate the data and table or database to other environments, like when you progress from dev to QA to this QA to staging and prod, and when you migrate to some other hosting center, then all the sequences you have to be careful to maintain the sequences. So for that reason, it makes more sense to keep some string constants as the unique identifier for the description rather than sequences. So for example, John Deere, I can choose this as the identifier. And what is the machine type ID? Okay, sorry. Column name is not the John Deere. Machine manufacturer ID. ID. And consistently choose the data type, character varying. That means if the ID is less than 20 characters, here I chose the 20, then it doesn't add any pad any spaces. It just only occupies that 8 characters or 12 characters. It is a primary key. So this is needed. I will tell you why. What if you don't choose the primary key? For now, I will let me delete these two things and add one more thing, manufacturer name. Character variant. This is a 250 characters long. And okay, let's save it simply. Let's not for now. So this is a different schema. I'm not creating it in the same public schema. And so from scratch, we are creating a different schema, and we have just one table now. So, okay, and tutorial schema, refresh, and tables. Okay, manufacturer, view data. You see, you don't, you are unable to enter any data here. And why? Because you don't have a primary key for your table. So let us create a primary key, set a primary key, then you see the difference. This data output pane will have a one extra row to enter the data. So that only appears once you put the primary key. Primary key is by default will be not null. So this one. And manufacturer name also let's put as not null, because we without a name the manufacturer doesn't exist. Let's save it and let us refresh it. Refresh it. Oh, you have to. Okay. Now you see you are seeing the additional column. Additional column. So that is to enter the new data. So let us enter the new data here. John Deere of USA is not needed. John Deere is the manufacturer name. Manufacturer name. And what is the primary key? So I will go with the string constants. Abbreviated kind of things. So 1, 2, 3 sequences. And there. So once you set the primary key, then you will be able to enter the data here itself. So till your program or program matures, you can use the this PG admin tool to enter the data into your metadata tables. And but at some point, you may if you truly deploy into cloud and say AWS databases like Aurora, Redshift, um, they are nothing but Postgres or SQL, MySQL, then it won't be easy to use this tool and connect to that and update these meta tables. One is security issue, and two is it is error prone, and by mistake if somebody deletes the artifacts, If you have, say, thousands of users, then you will lose all that. Say uh, your application will be in trouble. So it's not a good idea to edit the database data directly um, from these client database client tools. Always better to provide screens from your application, few admin screens to enter this data and modify this data for administrative side, and that way you can protect the security and all that. So once you enter it, don't forget to save it, save the data. Then only it will persist. Now I can run this query again. I will get the same thing. So this extra column only comes when you define the primary key. Now I have the manufacturer. I only kept the we've only kept the name of this manufacturer and the ID. We didn't carry the model or product line and other details, or even the machine types. Now let's go and create another table to define the manufacturer. Uh, Sorry, we had the manufacturer. Let's go and define the machine types. Table machine types. And say, obviously, we need to have a machine type ID. For a primary key. Data type, character varying is for character types, character varying works in the most of the cases. Is it a private key? Yes. Otherwise, we won't be edit the data here. And then machine type ID and machine name, type name, or just simply name. And say where character varying 250. And okay, it's not primary key. Okay. So I think it is simple enough. Save. Because here machine types just the top level machine types, so they don't carry any other extra information. So that should be good. Machine types. Okay, refresh. We should get the second table also, machine types and view data. Now let us enter the data here. So what are all the machine types we have? The tractor, the harvester, and all those things. Okay, let's say primary keys, tractor. So uppercase mnemonics is the enumerators, or mnemonic is the style we chose so that it looks like they are constants. Tractor. Second one is harvester. Save the data. So now we have two metadata tables, manufacturer and what are the machine types they support. Then comes to the actual types of machines they sell. So that we carry in model. So let's create a table for model. Model. And obviously model number or model ID is the primary key. Model ID, okay, not bad. Character varying. Say 20, the same consistently we are choosing the 20 for the IDs. Then model ID, model description, a product line, model description, character varying, 250. Then what is that? model description, and what is that? Okay, model description and say product line, character variant 2050. Then model also should carry the foreign keys. This model is sold by so and so manufacturer. That means manufacturer ID. Manufacturer ID. We borrow from the manufacturer table. So it will be a, so the type and length has to be same as the manufacturer ID. So that's why we consistently chose the character varying and 20. Also, it has to tell the machine type. Model doesn't, so instead of putting everything, all the details, we are only carrying the IDs of this normalized tables, machine type, type ID, machine type. Okay. Character varying. Okay. Okay. Then we have the machine type ID. Refresh, we have this one. So we have three, two columns, manufacturer ID, machine type ID, which are supposed to be foreign keys in the tables, machine types, and manufacturer. So let's create the constraint. So foreign key is a constraint. So expand the constraints column and create a foreign key. And what is the foreign key name? First, I want to create a manufacturer ID foreign key. Manufacturer ID foreign key. Okay. If you want to go here also another one, that's fine. So every artifact in database will have a name. We'll leave it for now. The local column, obviously, what is the this one? We are trying to create a manufacturer ID. So the column we need to choose is manufacturer ID. This is a foreign key for the manufacturer ID. Then references, which table it references. I want to borrow that ID from the manufacturer table. Okay, in manufacturer, there are two columns, ID and name column. Obviously, we need to choose the manufacturer ID. So this is the definition of the foreign key. Your local column references the column within other table so that you don't have to maintain all the other details and add it. Then see that warning went away, you will be able to save it. So let's create another foreign key for the, in the constant itself. Let's create the foreign key for the machine type ID. Manufacturer ID foreign key created, machine type. Let's create the type. Definition columns. Okay, local column and okay, machine okay, we created manufacturer and machine types. Machine types. Okay. Oh, we have to choose the local column as the machine type. Machine type ID references what table? Machine types. And what is the column? ID column. And add it. So that means the first those two things should exist to fill this table. Say for example, let's try to now the columns within this model table has the foreign keys. Let's try to fill it with a different foreign key and we should get a error to add any data. For example, let us add a model, this one, 1023. Okay, 1023, parent key, primary key, model description. Say this is subcompact tractor, and I think I want to add one series also here. One series contract compact tractor, and product line, say compact tractors. Okay. What if I don't fill anything here, or if I, let's see, will I be able to save it? Data saved. Okay. Okay. Manufacturer ID, manufacturer. What is the data they have? Okay, these are the manufacturers. And what is the machine types they have? These are the machine types. Now let's go to our table. Null it is accepting because it's a not null column, not a not null column. Okay, let's type some gobbledygook. Okay, let's try to save it. You see, you got error. Insert or update on table model violates foreign key constraint. What is the foreign key constraint? Whatever value manufacturer ID you type has to exist in the manufacturer table. Manufacturer table, this one, and you have to pick one of them. Manufacturer table is one of them. Say, let's pick one of these primary keys as per the foreign key requirement. Okay. Manufacturer ID. Okay. Now save it. No problem. Now mission types, let us add some gobbledygook. Will you be able to save it? No, it has some problem. So that is the mission type. Mission type. What are all the mission types? Mission types is tractor. Let's take this primary key, and let's enter that primary key here. Mission key type. Now you'll be able to save it successfully. So we could avoid those nulls. I believe we can come here and say in column definitions, we can put not null as, not null as. Then you won't be able to enter a row with nulls. So that is there. Then we have the metadata. So model is the final one artifacts where you need to refer to. So the model ID is the important. Say you want to add equipment, if you want to sell or buy equipment, model ID is the important one. From there you can get all other details. Oh, by the way, you can add, I think for model website URL also. Say like website URL. Definition, where character varying, and 250 should be enough for URL. And we can take here, and this is the URL. So for further details, without carrying too much let's do this. Too much data ourselves, we can just give a URL so that they can a user can go and see all the details. So that is one way, but minimum details we have to maintain so that we can lead to that. Then we have the minimum metadata available needed. Let us try to create a table to hold the particular equipment they are trying to sell. So they want to sell, farmer wants to sell equipment, is used equipment. What are the columns? The standard notion is equipment ID. Okay, here equipment ID. So this is a running equipment. You put advertisement, keep it for 1 week or 2 weeks, and sell it and all that. So here it makes sense to have a primary column as sequence, primary data type, say integer. If your application becomes wide, very very famous, then you can choose big int or something like that, and not null yes, primary key yes, and I think there should be a identity column somewhere, advanced roles, filter, constraint, partitions, parameters, security. Okay, let's keep it right now like that. So it's a primary key. Then equipment model ID. So this is the foreign key. So it is better you give a drop down and let the seller or buyer choose this rather than him typing the value. And but the onus is on the application to maintain the all the available needed types and all that. That's why you have to keep updating this model table and some model ID. Then what is the other one? How old is it? Is it used or new? If you want to put a boolean variable, you could put boolean. Again, you okay, boolean. Okay, then also, okay, how old? User months. It's also integer because we put in the months. So sometimes you have to take the value conveniently. So user months, then what else? Mm, what else? Mhm. Okay, user months and okay, pin code, zip code, and what zip code this is available. And for now, let us maintain as a character variant, length say 20, and price. That is the most important thing. I think money data type is available. Money, and save it. Now let's go to equipment table. Equipment table has one foreign key. It refers to the model ID. Okay, let's create that one. Model has model. Okay, model and model. That's good. Let's go to the constraint of this equipment table. Let us create a foreign key. Equipment primary key. Model foreign key. Oh, this is the actual schema, not the public schema that we have before. Oh, okay. Equipment did we create here? Refresh model. Okay. Tutorial schema, refresh. Okay, model is there, equipment is there, columns, equipment ID, model ID. Okay. Now model ID has to refer to the model ID of the model table. So let's create a foreign key constraint here for the equipment table. Create foreign key constraint. Foreign keys. Model foreign definition columns. Local column is model ID. Is the model ID? Okay, model ID. and differences table model, differences column. Okay, we should have put model ID here also, there also same, and add it to this one. This is the foreign key. Now it refers. Now in the equipment, if we try to add some gobbledygook, like say equipment ID 1, model ID, say gobbledygook, and try to save it, it throws the error, foreign key error, because this foreign key doesn't exist in the model table. So that's where you have to get where is the model table? Model table is model ID model table. So let us take this model that we created one and try to create equipment for that. Okay, it takes okay, data saved, because others we didn't keep it as a um, user is true, user months is say 15 months, zip is say 926, 89, something like that, and the price is say 4,500. So now we can save it. Oh, why did I enter here? Horrible. Okay, thanks God. Should be able to delete this row. How can I delete? Okay, delete. Come on. Okay. Let's create the zip 9281212 or whatever. And price is 5,000. Okay, save it. There's a null column here. Okay, remove it. It should be take it out. Remove it. And okay. Remove the table. That's fine. Okay, let's add about two character ID 1023. Same thing, because we don't have. Say, let us see. Let's say another guy is selling the same thing. Yes, it is new. So user is false. So user once it is false, you have to set it to 0. Say some zip ID, price is say 9,000. So that's how you create the foreign keys and refer back to the metadata. And I hope we are able to give some idea about this idea to application to schema, how you transition your thought process and start building your applications. Thank you very much.